everyone, let's solve today's daily LeetCode challenge question. Let's look what the question is. It is easy, so it should be easy. 1 4 3 6 destination city. You are given the array paths where paths I is equal to city I, city AI and city B. Means there exists a different direct path from going from city. Okay, there exists London to New York. Okay, return the destination city, that is city without any path outgoing to another city. Return the destination city, that is the city without any path going to another city. It is guaranteed that the graph of paths forms a line without any loop, therefore there will be exactly one destination city. Okay, so it means that what this means is, if this is a path, then it means that there is a flight going from there is a flight that is going from London to New York, and New York to New York to Lima, and Lima to Sao Paulo. Okay, so we know that, and they are saying that it is guaranteed that this will just form one line only. There will not be an array like from Lima to New York again, or from Lima to London again. There will just be directed one directional kind of thing only here. There will be no any loop. So what we need to find is, we need to find the destination. Where does this end? We need to find the destination. Okay, so how can we do that? Let's see. If this is another path, then let me try to find. So there is B, from B there is going to C, right? So B is going to C, and D is going to B, and C is going to A. So how will I find what is the destination? I do not even know what is the beginning, right? If I knew what is the beginning, then I would know what is the destination. So how would I know which one is the beginning? So it is B. I guess I don't know what is it. What is the beginning by knowing the destination, I guess, because right, so C, B, A, and D is not here. So I think that D is the start point. I'm just guessing that D is the start point because there is no D here, right? So since this is just the start point, so there will be no any, there will be no any path from somewhere to start, because there is a start here itself. So I think this is D. So D is going to B, B is going to C, and C is going to A. So I guess A is the answer. Yes. And if there is A, Z, then obviously Z will be the answer. Fine. I think it is easy. So first of all, what I need to do is, I need to find which point is the starting point. And if I know which point is the starting point, then I can just build a hash map like this, and then just go, okay, if D is the start point, then D goes to B, B goes to C, C goes to A. So A is the answer, right? But first question is how to find the start point. Finding the start point, I guess I'm thinking that first of all we should build a hash map, and first of all, like one approach to find the start node, one approach to go destination to find the start node is whichever node is not in the destination list, right? Is the start, isn't it? Does it make sense? Like, see here, from London to New York, New York to Lima, Lima to Sao Paulo, right? So New York, Lima, and Sao Paulo all are in the destination, right? All these are destinations. Only London is not the destination, because London is the start point. So that is one approach, but I think to do this approach, the code will be too lengthy. So is there any other good method to find the start point? I guess. Oh, okay. So there is also another one. Only the start point does not repeat twice, right? If in this array, in this hash map. So if you see, if D is the starting point, then D to B, right? So if you look at here, then London to New York, and New York again repeats here. Lima also repeats here. So only the starting point does not repeat twice. So another approach is, I think that is the good approach actually. Another approach to find start node, one approach And another approach is just go through the hash map, and so whichever occurs just once, whichever occurs just once uh, just yeah whichever start whichever what do you call this? If this is destination, then what is this? Whichever start country, whichever start node occurs just once, is the start node, is our ultimate, is our first start node. Okay, do you know what I hope that you understand what I mean. So here, uh, from London to New York. Okay, so London might be one, but there is another New York, right? So New York is twice, and Lima is also twice. So yeah, I think that this is another approach. Are there any other approach to find the start node? I think this will work. So let's code for this approach. Whichever start node occurs just once is the first start node. But what about this coding? Whichever node is not in the destination node is the start node. I guess so. C, B, and A, and we have A, B, C, D. So whichever is not in the, I think this one is easier to code, so I'll just code this. Okay. Another approach, whichever start node occurs just once is our first start node, right? So first of all, I'll create a hash map for the path, and I should also keep track of which one just occurs one, which start node just occurs once. So yeah, B, D, C, which one just occurs once? How will I keep track of that though? B, D, C, A. Interesting. So it means that along with this map, I also need to keep track of the hash map, or what? Or instead of hash map, what if I just keep track of B? B is coming up 2 times, and D is coming up 1 time. So there are four paths, right? A. So there are so many ways to do this. So A is coming up 1 time, B is coming up 2 times, right? C is there 1, 2 times. A 1 time, B 2 times, C 2 times. A1, B2, and C2, and D1. So it means that either A or D is the start, is the so it means, so all other also comes in between, right? So it means that B and C are the transit, and A is the start. I mean A or D is the start. So it must be A or D. One of the either A or D must be the start or destination, right? So yeah, I mean that is also one way to find out. So because if you see here, then London will be counted 1 time, Sao Paulo will be counted 1 time, all other will be counted 2 times. So it means that whichever just counts 1 time, that will be our start or destination. So what we can do is, we can just create this hash map, and while we are creating this hash map, we can just count the number. Okay, count any number. Yeah, so let's do that. And whenever we are counting the number, if anything each greater than 1, because it will only be either 1 or 2 times, right? Because if it is a transit, then New York will appear 2 times, Lima will appear 2 times, only this or this will appear 1 time, London or Sao Paulo. So when we are going through this list, London will appear 1 time, New York will appear 2 times, Lima will appear 2 times, and Sao Paulo will appear 1 time. Okay, so it means that, so let's go through this list. Means that, so B is going to C, and it will, and B is going to C, and B will appear 1 time, and D is going to B. So B already, B has appeared 2 times now, and D has appeared 1 time. Okay, and C. Um, so actually I'm just trying to optimize it, but do I even need to optimize it? I can just code directly. I don't know. Okay, let's not optimize. Okay, let's just code whatever we have. So what I will do is I will just keep track of the numbers, and keep track of the, and keep track of the, of this list. So let let asmap is equal to, because I'm sure that there is a better optimization here, but let's not optimize. Let's asmap is equal to, or should we optimize? Actually what I'm trying to optimize is, what I'm trying to, what I'm trying going to code here is, I'm going to create a asmap for start to destination. I'm also going to create a asmap for this list, you know, how many times it appears, and I will only, actually not how many times it appears, but I will only add I'll create a possible start node. Actually what I can say is possible destination. What I can say is possible destination. So possible destination list will only have 2 nodes. Okay, which will occur 2 times, which will just occur 1 time. So basically I need to create another asmap, which, yeah, basically what I'm saying is, I'll create a possible destination list, which where the nodes only appears once. Okay, and possible destination list. So A only appears once, and D only appears once. So whichever only appears once will be so whichever, I mean, I can just create this asmap and this, right? So D is in the start node, so A must be the answer, right? So this is one approach. Actually another approach, I just came up with another approach. So just like this, whichever node is not in the start node will be the destination node, isn't it? Whichever node is not in the start list is the destination node, right? So why can I not follow this approach? So I can just actually create a set of all the start list: London, New York, and Lima. London, New York, and Lima. And I can create a set of all the nodes, and whichever one is not in the start list, E will be the destination node, right? So why can I not do that? Let's do that. What do you say? So let start nodes is equal to new set. So this will be my start node, and let all nodes, this will also be my all node. Okay, and then I can just go through all the paths. For path of paths, I will just now, for path of paths, or I can say actually for start to end of paths, right? So this will be start and this will be end. So start nodes dot add, I'll just add this as start node, and all nodes will have So whichever node is not in the start list is the destination node. Dot add start, and it will also add in the end. Right? And whichever node is not in the start list, so at last it will be, all nodes will be BDC. So at last start node will be BDC, but end node will be BCDA. Everything, all nodes will be everything, and start node will just be BDC. So because destination is something which do not have any start, isn't it? Because all other nodes we will start from there, right? So if we say that this is a flight, then we will start from London to New York, from New York also to Lima, but only we only in that Sao Paulo, right? So we do not start from Sao Paulo to go anywhere, so it will not be in the start node. So it means that, can I do just minus all nodes minus start nodes? Is this possible in JavaScript? I'm not sure if this is possible or not. Let's see. Can I difference two sets JavaScript? Yeah, that's what I mean. A and B. So 1 2 3 4 1 3 4 7. So that the answer will be 2. I want answer 2. Okay, there is no any good way. It's just A dot filter element B dot includes. I should just, okay, there is no any shortcut like that. So what I can do is, there is no shortcut really. It's so hard to believe. Okay, there are no any shortcuts like this. So return, what I can say is return difference start node minus. Okay, I will just create this function myself. So if there is set 1 and set 2, then what I should do is, I need set 1 minus set 2, right? So it will be, I need BCDA minus BDC, right? So it means that I need to go through all the sets. So I need to go through if all all nodes, start nodes. So this is all nodes and this is start node, right? So if all nodes actually, if small set has str, if it does not have str, then return str. Okay, yeah, this is the answer. If it does not have, so it means that a it does not have, right? So it will return str. I hope this works. Yeah, yes. Oh my god, it is just one day. Okay, anyway, it will not be one day. I will buy time ticket and then solve yesterday's question as well. Let's see editorial. Brute force has set. So what is the set approach? Outer for loop to log in within inner for loop. We'll create instant that represents all cities that have an outgoing path. We iterate over paths for each index and add. We can iterate and select the candidates as we did in the. Now we have outgoing, so we can simply check if. So we have initialized our asset as outgoing. As outgoing. Oh, okay. So this is the start nodes. They also initialize the asset as outgoing. So all the start node as outgoing, right? And then iterate I over in indices of paths. And add paths I0 to as outgoing, right? And yeah, that's what I did here as outgoing, and iterate I over indices of paths. And if candidate is not in as outgoing, then return candidate. Yeah, actually, I could have done it here only. You know, um. So what I did here is I created start nodes and I created all the nodes, and then I returned the difference, right? But instead of doing this, um, but it is the same time complexity and same thing. But what I could have done is I could have uh, just made start nodes, and then at another time I could have gone through the paths again and then see if, and see if any node any any node is not in the, you know and see if any like destination node is not in the start node or not. So that would have been one answer. It is the same thing though. Okay, yeah. So this was one approach that I found, and another approach could have been, yeah, that approach would have been more, the approach that I was going to take. It contain the, like, create a hash map first, and then find out how many times two or one time, and then after finding a start node, then go through that again. That would be a longer approach, and this is a shorter approach. Actually, I mean, I solved this without even thinking properly. It was just a rush. So I hope that it is good. It is for good.